Now next is, I said you that elements can be classified into metals, non-metals, metalloids and inert gases. The first will come to the metals. Alright, first will come to the metals. Now metals, if you see the characteristics of the metals, then you will find they have got a bright luster, they have got a metallic luster, which we can say that a metallic glow like silver, like what you can say gold, like copper. They have got a metallic glow, it glows, we can say that. They are generally hard, they have got high melting and boiling point, hard, very hard. For example, let us say this is a silver rod or iron rod, it is very hard, except sodium, which is soft, we can say that, which is soft, sodium, potassium, which is soft. It is so soft that it can be cut with a knife, except there are some exceptions also. Alright, now what you can say is that lead, they have got low melting point. I said you that they have generally high melting and boiling point, but lead is having a low melting point, we can say that. Clear? Lead is a metal, which is an exception. Remember it, exceptions are very, very important. They generally come in the exams. Now they are good conductors of heat and electricity. Metals are very good conductors. However, tungsten is a poor conductor. We are using tungsten in the bulb. Tungsten is there. It's a poor conductor of heat and electricity. They are malleable. Malleable means they can be beaten into sheets. Malleable. M-A-L-L-E-A-B-L-E. Malleable. You have heard it, this word. Malleable and ductile. Alright. Malleable means beaten into sheets. We can say that. And ductile means drawn into wires. Alright. They can be beaten into sheets. Metal can be beaten into sheets. Metal can be drawn into wires. Alright. So they are highly malleable in nature. Metals. Alright. They are highly malleable. Alright. Except zinc, which is not ductile. Zinc is soft, so to say. It is not ductile in nature. It is neither malleable nor ductile. And the most malleable metal, you have read it in the earlier chapter, that is gold. We can say that. Most malleable metal, we can say. Zinc is neither malleable nor ductile. It is soft. Zinc, we can say that. They are sonorous. They produce sound on striking. If you strike a metal, one metal with another metal in this way, of course this is not a metal, mind it. Of course it's not a metal, it's plastic, but this sort of a sound is produced. Alright, you are ringing the bell in your school, you can see the bell. So bell means what? One metal is striking another metal. So then only the sound is produced. Hence it is known as sonorous. We can say that. They are sonorous. Alright. Now next is they produce a sound when heated. When you are heating. Now heated means not heating. Means one substance is heating with other. That's called heated. Alright. Clear. So then 80% of the elements which are known to us, they are mostly metals. Now let me tell you about the metal that hydrogen is the lightest element. Hydrogen is not a metal, mind it. It's a non-metal. It's the lightest element. I am saying you certain facts. Helium is the second lightest element. Helium is the second lightest element which is known so far. Iridium is the heaviest element. It's having a very high density. Iridium. Alright, you know how much density is? Generally, mercury was considered as a high density, 13.6 gram per cc. Gram per cc, 13.6. Mercury, the density was. But now we consider iridium. Iridium is 22.6 gram per cc. The density is very, very heavy. Iridium exists. Alright, lithium is the lightest metal, zinc is not malleable, neither ductile, I have said you. Bromine is a liquid non-metal, remember it, bromine is a liquid non-metal, similarly mercury is a liquid metal. Mercury, gallium, alright, they are existing in the liquid state, but below 30 degrees Celsius, below 30 degree, remember it. Alright, tungsten is a poor conductor of electricity, oxygen is the most abundant, I just said you just now, oxygen, silicon, they are the very abundant element. In this way, gallium I said you, mercury I said you, and one more element, sorry, cesium, one more, I forgot to say you, cesium, that also exists in the liquid state below 30 degrees centigrade. They are the liquid metals, we can say that, but below 30 degree they exist in the liquid state, fine. Now next is, if you see the non-metals, they are just having the properties opposite to that of metals. So if you remember the properties of metals, then the properties is opposite of non-metals. Like metals I said, they are having luster, metallic luster. They don't have a luster because metals generally are solids. Generally they are solids except few, that is cesium, mercury and gallium, which is below 30 degrees centigrade, it exists as a liquid. Otherwise all are solids. Alright. Similarly, non-metals are generally liquids and gases. They are generally liquids and gases except graphite, which is a solid. Graphite, carbon, it's a solid, we can say that. Now, next is they don't have any luster, they are brittle in nature. Brittle means easily it breaks. Graphite, it breaks easily. Alright, it breaks easily, we can say that. They are a bad conductor of heat and electricity. They never conduct heat and electricity. Gases and liquids, we can say that they do not conduct electricity. They do not conduct heat, we can say that. They are poor conductor of heat and electricity except graphite, which is a good conductor of heat and electricity. Graphite. For that reason, graphite is used as an electrode. In battery, it is used as an electrode. In your cells, That is also battery, secondary cells. You're using the, what you can say, in your house, the inverter you're using, the cell is there, the battery is there. There we are using, but not graphite there, we're not using graphite here, of course, we are using copper or zinc electrode there. But it can be used. It can be used. Graphite electrode can be used. Alright. In the battery it can be used. In the dry cell it is used. Dry cell. Graphite is used. It is not malleable, it is not ductile, it is not sonorous. Alright, in this way. Similarly, metalloids. So metalloids means which possess the properties of both metals as well as non-metals. So generally group 14, when you will study periodic table, you will see group 14, group is there. In a periodic table basically is divided into horizontal rows, that is called periods, and the vertical columns, they are called as groups. Alright, so there are 18 groups are there. So group 14 is generally considered as a metalloids. Group 14, remember it. So what are the elements are there? Germanium is there, arsenic is there, carbon is there, antimony is there, tellurium is there, boron is there, silicon is there. We can say that. Clear? Group 14 elements. They are considered to be as metalloids, which possess the properties of both metals as well as non-metals. And the noble gases already I said you. Helium, neon, argon, krypton, xenon, radon. We can say that. So they are the rare gases or the noble gases. So they come under, we can say, elements. The elements is divided into metals, non-metals, metalloids, and the noble gases, so to say. Now compound is a pure substance. Let me tell you what compound is. A pure substance formed by the union of two or more elements. Alright, in a fixed proportion by weight. Already I said in the beginning itself that compound is being formed by the combination of two or more elements, but not by any ratio it will combine. It has got a fixed ratio. By fixed ratio it combines. By fixed ratio by volume, by fixed ratio by weight it combines. And then it forms a compound. It's not by any ratio, mind it, not by any ratio. For example, sodium chloride is a compound, you know that, NaCl. So the atomic weight of sodium is 23 and Cl is 35.5. So in this ratio by weight, 23 is to 35.5 by weight, it combines sodium and chlorine to form sodium chloride. Similarly, water. Water, it is atomic weight of hydrogen is 1. So 2 hydrogens, it is 2, is 2, and atomic weight of oxygen is 16. 2 is to 16 means I can simplify it as 1 is to 8. So 1 is to 8 by weight, it combines to form water. To form water, we can say that. Similarly, if you write the equation 2H2 gas plus O2 gas gives, what is that? 2H2O, either liquid or gas also, you can write it down. So by volume also, it is 2 volumes and this is 1 volume. Fixed it is. The ratio is 2 volume is to 1 volume. By weight it is 1 is to 8. By weight it is 1 is to 8. Hydrogen and oxygen combines. Hydrogen is to oxygen, it combines in the ratio 1 is to 8 by weight. And hydrogen is to oxygen, it combines in the ratio of 2 is to 1 by volume. Alright, when you will do the electrolysis, if you want to separate the components of compound, I said you, it cannot be separated by physical means, but it can be done by chemical method. In case of elements, physical and by chemical method, you know that. In none of the method we can separate we can separate the constituents of the element. Alright, we can't do it by neither by physical or chemical method. But by chemical method, we can separate the constituents of a compound. For example, if you want to separate the components of hydrogen and oxygen, what you need to do? You need to take acidulated water. Means what in water you will be mixing some acid, because pure water is a non-conductor of electricity. But when you add some acid to it, it becomes conductive. It becomes conductive. Pure water. Alright, distilled water, you add some acid. Which acid? Sulfuric acid. Then it becomes conductive. And that is a substance, it is there in your home, in your, what you can say, home means in your, that is inverter, which you are using a battery. In your home, you might be having a battery inverter, isn't it? From which the current, you are getting it when the current goes off. Alright, when the current goes off, you are getting it or not? Yeah. So there the electrolyte which is being present in the battery, what is that? That is nothing but dilute sulfuric acid. We can say that. Clear? So in this way, what you find is that if you want to separate the constituents of water, that is hydrogen and oxygen, what you need to do? You have to go for electrolysis. By passing electric current, you can separate the constituents of water, that is hydrogen and oxygen. So hydrogen and oxygen, when you will be collecting in different, what you can say, electrodes, then you will see the by volume will be 2 is to 1 by volume. Means if 5 cc of oxygen you have collected, then 10 cc of hydrogen you will be collecting it always. Because by that ratio it combines, and by that ratio also it separates. Alright. So this is about compound. More I will say you in the next class. Thank you.